So what do you talk about when you design a network? I want to make sure I scale this. I want to make sure I grow my company. Most companies want to grow, want to keep expanding, but things you want to make sure you take into consideration when you do this. There are several things you need to think about. One is network documentation. I want to make sure that I know the physical and logical topology. I want to make sure that when I get an error message, I know, or I get a device that fails, where is that device located? Which floor is it on? Which desk is it? So that it's easy to track. So, and also, if I'm changing something back in the network, back where the switch is or the hub is, that we know where all the information is, so that I'm not guessing. Some of the worst places I've been, when you look at, go back and see the switch layout, and you've got 1,000 cables in there, not one of them's labeled. You don't know where they're going, you don't know where they're coming from. So if a device fails, you see a light that's gone dark, but you don't know why. You don't know which one it is, and it takes a whole lot more time. Another thing to think about is device inventory. How do we keep track of what equipment we own? Of course, you've got to think about your budget. How much budget you have year to year to keep buying network equipment. So you want to make sure you're considering all that. And then, of course, traffic. How much traffic am I going to use? What protocols, applications, amount of traffic we're going to put on the network are all things that you need to keep in mind when you're designing that network. Now, protocol analysis is as your network grows, so does your traffic, and maybe the type of traffic that is running. So you need to understand that type of traffic going across your network. And there are definitely several management tools out there, but you can use Wireshark to check what's going on. And of course, we know how to use that. A little more experience, you could be an expert at knowing which packets are running across your network, what time of frames are going on, so you can make intelligent decisions going on. Here's an example where they're capturing IPv6 and IPv4 protocols, and the IPv4 output reveals that that a host has used DNS, SSL, HTTP, ICMP, and other protocols. So you can tell what's being used and how it's being used. But another thing you need to think about is, okay, what is my traffic flow? Capturing traffic at peak times. What is my peak time? Have I engineered my system to handle that peak time? So is my big business from 10 till noon, and then from like 2 to 4? Making sure that I design enough equipment into the design. And also, is there enough redundancy? Am I getting bottlenecked someplace in the network? Those are just things you want to think about. The other one is, how do your employees use your network? Which operating system, what CPUs are they running? Kind of how are they utilizing their RAM and disk drive, so that you know when's it time to start upgrading computers. So just something to keep in mind. And this shows you a little bit of how to get, show your network which applications are running, how much they're running, and going from there. So now let's go to, I'll put another one in here. Let's go verify connectivity. Let's get past all this, a couple of videos into one here. Of course, what are you doing? You're very familiar with the ping command. And of course, if you're small or large, if you want to make sure things are connecting, you can use the ping command. Ping command is an effective way to quickly test layer 3 connectivity between source and destination IP addresses. We know that ping uses the ICMP right, protocol, and we're just verifying certain response times, sending a request, getting an echo back. Just knowing that that is possible, and we've played with it enough to show connectivity, and you want to make sure that that's taken care of. Now, if certain devices are not connected, you've all seen this, probably in a few of your labs, where things are successful or not successful, and you want to make sure that you understand what happens. Now, keep in mind that when each of your operating systems gives you different response to ping indicators, the exclamation point means it's a success. A period means it expired. It waited too long in that time, and then uppercase U means it was unresponsive. So it gave you unreachable destination. Now, in some cases, you can extend that ping, and I don't know if we talked about this much. I mean, I can edit the ping command to change how big a message I'm sending, how much time I'm spending. So if you just type in command ping and then hit enter, it'll turn you into it'll give you some prompts to customize that ping command. Just give you scroll down here a little bit here. So you type in ping, and what did it give you? It asks for a target, and then you can start changing how many times you want to repeat. Default's 5, you can change it to 10. How big a packet are you sending? 100? 1,000? Depends what you're trying to test, how much you want to time out. So there's a lot of modifications you can make to the ping command to see if certain things, how fast or how much you want to test your network. If you're just testing connectivity, then more than likely you just want to make sure that IP addresses are correct. But in some cases, you may want to test, do I have a bottleneck? Is data going to be slow? What happens if my packets are larger? And what happens to the network and what kinds of response? Of course, we know the trace route command quickly determines the layer 3 connections, and the question is, how long does it get along the route? How far does it take? How many routes does it take to get to where you want to go? So it's just one way of testing that network out. I think you've had a couple of labs in that, so just a way to play that. As with ping, you can do an extended trace route where you can change other modifications, other devices, other sizes, how long you want things to last. So how many hops? You want to limit the number of hops before you kill a packet. I'll let you go through those a little bit. And then if you're going to keep your network in a long time, you want to make sure that before you start monitoring or troubleshooting, you need to understand you've built this network to a certain design, and you want to make sure that's the way it's designed. You set it so that any other changes you make to it in the future, you can tell if it improves or hurts the performance of the network. Well, the only way you can do that is compare it to something. Well, a network baseline is once you've laid out and designed your network, you want to keep track of what happens on your network. So in this example, they're doing a ping on August 19th, and then they'll repeat it a month later and see, am I getting that same response time? Is it still happening? How many milliseconds is it taking? How long is it taking to get there? Well, took it a whole lot longer the second time. Then the question is, okay, is that acceptable? So as you're keeping track of your network, you want to run certain benchmarks along the way. Initially, when you get a system up and running, you say, here, this network is running at this speed, this connectivity, this trace route. And then as you're making modifications, as you're adding people on the network, you want to keep track of it and say, hey, is the network getting better or getting worse? And you always want to make sure you save this benchmark so that you can go back and compare it to it, so you can make that comparison and decide, oh, too much, too little traffic that's going on. So just one way of keeping track of information. Let's see, did I assign you I didn't assign you the lab. I think there's a packet tracer. So I'm going to stop the video here and we'll go on to the next one on hosted iOS commands.